2012 is a primary 6 from Qifa Primary School. Welcome back to another lesson for physical chemistry. For this lesson of physical chemistry, we'll be continuing to learn about the Maxwell-Boltzmann distribution. But for this lesson, we'll be revising about diffusion and osmosis. So last lesson we compared the differences and the similarity between diffusion and effusion, and through some of these definition, meaning, and all those. So for this lesson, we'll be comparing diffusion and osmosis. So over here we have a few things you're going to compare about. So the first one is the definition, or else known as the meaning over here, which is the process of it. Like, what is the process of the diffusion of the osmosis? Well, the second one is the substance that had moved during the diffusion and the osmosis. Like, is it a solute that moved or the solvent that had moved? Well, for the third one, it is a medium, basically the space where the diffusion or osmosis happen. Well, for the next one, prevention, is it possible to stop diffusion or prevent diffusion or osmosis? Well, for the variables, is that what variables are there going to be? Well, before that, there's the requirements that have, like, what must there be for the diffusion or osmosis to happen. Then the flow direction is to see in which direction the molecules go and all for both diffusion and osmosis. Well, the condition, and then there's the conditions and the results. So let's start out with the diffusion definition or the meaning. So diffusion, although we have already explained it last lesson, I'm going to explain again. And so diffusion is the process of molecules So diffusion is the process of molecules moving from a region of higher concentration to a region of lower concentration. While for osmosis, it is also the process of molecules moving from so the in front part is the same. So Okay, so for osmosis, it is the process of molecules moving from a region of higher concentration to a region of lower concentration through the semi-permeable membrane. So over here for both diffusion and osmosis is the process of molecules moving from a region of higher concentration to a region of lower concentration. But there are two differences. The first one is that for osmosis is that the process of the molecules moving must pass through the semi-permeable membrane, and the second one is for diffusion, for the concentration is for both the solvent and the solute, but for osmosis, if you want to say the molecules, which is basically the solvent, is moving from a region of higher concentration of the solvent to the lower region of, a region of lower concentration of solvent through the semi-permeable membrane. So for this part over here, the molecules are always the solvent, okay? So the substance that move is, so over here for this one, before that, the diffusion, how it happens is that it's like one region have a higher concentration of both the solvent and the solute, whereas you just like spread out equally if you're going to explain it like that. Well, for osmosis is that it's like there's definitely a membrane in between, and compared to diffusion, whereas there can be a membrane in between. There can be a membrane there can be like a wall with holes there. It's like it does not matter if there is a barrier or not, and if there is a barrier, it also does not matter if they have holes or anything. Well, for osmosis, is that number one, it must have a semi-permeable membrane. So it's like well, for this part, the other thing that only the solvent can pass through. The solute cannot. Okay, so for this part over here, if you want to like most of the time, where do you hear osmosis from? Is that from diffusion, and diffusion like from past lessons is like compared to osmosis, it's just like normally when you think of osmosis, you probably think about like cells and all those, like because the cells in no matter plant cell, how animal cell or whatever cell, there's always the semi-permeable membrane, whereas the semi-permeable membrane will only allow certain substances to go in and out of the cell, basically the cell membrane. Well, over here for this part, it's like how osmosis happens is that because normally when you listen like for osmosis is that had the cell taken the water and all those and the different types of solvent. Well, for this part, it's basically a similar thing. It just that it's not necessarily a cell. It just there's a barrier, okay, and the barrier is the semi-permeable membrane, and the only thing that can go through is the solvent. Well, the substance that can move for diffusion is that both the solute and the solvent both solute and the solvent can move freely inside the space, okay? Well, for osmosis is that only the solvent molecules can move. And even while moving, it is also not freely. It's like it needs to pass through the semi-permeable membrane. Okay. So the medium, where as I've already explained, is the space where the process happens and all. So what is the medium for diffusion? So there are two things I need to say about. So the first one, which I'm going to say first, is that it can most commonly gas and liquid. Okay. Because that is like gas and liquid, the molecules can move like freely, while for solid it's not that well. So it's mostly for gas and liquid. Well, for osmosis, it is liquid only. Well, for the second one is that it can happen for both similar and dissimilar. Both similar and dissimilar solutions can be the medium, okay? It's like it doesn't necessarily need to be the same kind of solutions. Well, for compared to osmosis, it only allows us similar solutions. Similar solutions only. Well, over here, sorry for the spelling mistake. Well, for prevention, let's see. For diffusion, it's impossible to prevent it. So I'm just gonna write impossible here, because especially like you can't just use so give me a sec. It is impossible to prevent it. Like even right now, when people, it's like anywhere, it's like because it is practically impossible for all the molecules to be completely evenly spread out. Like so if you want to know more about for that part, well, you can go back to last lesson. Because the diffusion, it is only approximately accurate. It is only approximately completely even. So it's impossible to like prevent diffusion. It's like even now there can be some gases, like the molecules can be moving from higher regions with higher concentration to regions with lower concentrations. Well, for osmosis, it can be prevented by additional pressure. Because that's, so if you're going, it's like in the future lessons, you may also talk about like not just diffusion, osmosis, and all those. Well, for this part, by additional pressure. Okay, so it's like for osmosis, be like all of these things can be like related and all. Also, if you want to like compare, is that for osmosis, is the molecules moving, although it is from the region with higher concentration of solvent to the region of lower concentration of the solvent, and it is also through pressure that you can pass it through the semi-permeable membrane. Okay, alright, now for requirements, there is no requirement for diffusion, because like for diffusion, they can mix together and all, okay? So for the requirements of diffusion, you don't need to have something extra or something, but for osmosis is that there must be a semi-permeable wall, membrane I mean. So there must be a semi-permeable membrane, and also for this part, for the requirements is that for diffusion it can happen anywhere, anytime, so yeah. While for osmosis, there must be a semi-permeable membrane that the molecules pass through, okay? So the variables that affect diffusion, one of them is the presence of the particles. The amount of it doesn't actually affect the diffusion. It's like if there is that kind of particle or not. On the other hand, for osmosis, it is not about the presence of the particle, it is the amount of it. So it is the amount of particles. So over here, there's a first one, so well, for the second one is like for diffusion, all particles move from a region to another. So, okay, so it's not like this. While for osmosis, on the other hand, is only the solvent, that's the first one, only the solvent moves from one side of the solution to the other. Okay, so for diffusion, first is that the presence of the particle affects the diffusion. Second is that all of the particles will move from region to another. And what I mean by that, it's not necessarily that literally all of the particles move. It's like all types of it. Okay, wait. While on the other hand, for osmosis, only the solvent moves from side of the solution to the other side. Okay. So now for the next part, the flow direction. So the flow direction, it is. So for diffusion, it is to all directions. Okay, it's like from basically from a region to another. So it is. It basically moves freely. Okay. Well, for osmosis, it is basically from. So the flow direction for osmosis is just to the other side of the solution. Okay, it's basically through the semi-permeable membrane. To the other side through the membrane. Okay, so for this part over here, the flow direction for diffusion is basically to all directions, like it just has everywhere, while for osmosis it just through the semi-permeable membrane. Okay, well for the conditions over here, so whoops. Well, for the conditions over here is that it cannot be stopped or reversed. So it's like the for diffusion, it cannot be stopped nor reversed through pressure. That's definite. Well, for osmosis, it can be stopped and reversed through additional pressure on the other side on the solution. So over here for this part, it basically can be stopped through excessive pressure. And now last but not least, for the results, it's basically after diffusion happens. In the ideal case of diffusion, after it finishes, the concentration of each region will be the same. So the concentration between all of the regions will be the same, okay? And although it may be like the ideal case and all, but for osmosis, even after it finishes and all, and its ideal case and all, the concentration in each region will not be the same, okay? The concentration would not be equal, because that even if the two sides heights are equal, because that it's literally just the through the cell, the semi-permeable membrane, in those two sides it may be equal, because it is only if there is a semi-permeable membrane and if the molecule goes through it. But if you're talking about like one region itself and it is not through the semi-permeable membrane, then no. So the concentration will not be equal. Okay, so that'll be all for this lesson for the comparison between diffusion and osmosis. So just take one quick look, and yeah, that's all. Well, thank you for your watching.